Welcome to the lecture series of numbers and divisibility. In today's class, we will be learning a very interesting concept of mathematics, which is cryptarithm. Now, this sounds new. Cryptarithm, we can, in simple words, if you say, then it is a technique or puzzle where the digits or numerical digits are replaced by alphabets, and this way we express many mathematical expressions, maybe in terms of all the alphabets or maybe in a mixed form where we will have digits as well as alphabets. Now this is also called alphametics. That means this is the concept of mathematics where we involved alphabets also. Now if we go by the literal meaning of cryptarithm, then it has a word crypto, and by crypto we know that it means concealed or secret, and by rhythm what we understand is it's a pattern. So we can say it's a kind of secret pattern in mathematics. So if we have some data which is in the form of numerics or numerical digits, and if we don't want to show the actual information, and if we want to hide the whole information or maybe some part of that, then we can use the technique of secret pattern, which is cryptarithm. So this is, we can say, an encrypted data. Now in this class we will learn addition, subtraction and multiplication by using this technique called cryptarithm. So let's start the class. First we will start with addition. Now here, as you can see here, we are adding two-digit numbers, but we cannot say really that they are two-digit numbers, because both the numbers are represented by alphabets, and when we are adding these two numbers, both the numbers are same. We know the result of addition, where we have the result of addition is a three-digit number, where two digits, the digit at tens place and digit at hundreds place, they are replaced by alphabets, and only the digit at units place, that is given in the form of digit. And by the help of this expression we have to find that what this A and B they actually hold, what value. Now every alphabet here will correspond to a numeric value. So let's analyze this expression and let's find the value of A and B. Now A and B both will have the data, will have the value between 0 to 9. Now when we are adding to A, now A can have value from 0 to 9. When 0, if we assume that A is 0, then 0 plus 0 cannot be 8, so it's not possible. 1 plus 1 cannot be 8, 2 plus 2 cannot be 8, 3 plus 3 cannot be 8, 4 plus 4 it can be 8. That means the first possibility is A could have value 4. Fine. Then we will also analyze further that whether there are any other possibility of having any other value for A or not. Now we will continue with from 5. Now 5 plus 5 is 10. 10, and at units place the value is 0, so it is not possible as this value is 8. Now 6 plus 6 it is 12, so that is also not possible. 7 plus 7 is 14, not possible. 8 plus 8 16, not possible. At units place the digit is 6. 9 plus 9 it is 18, so 9 plus 9 it is 18, and at units place the digit is 8. So the second possibility of A having value, that is 9, so A could be 9 also. Now as I said that the value of A and B here will be between 0 to 9, so we will not check further. So now there are two possibilities that we have seen so far. A is equal to 4 and A is equal to 9, and we will evaluate this summation for both the values, and we will see what could be the value of B. Now suppose if we take the first case when A is equal to 4, that means here the form of addition will be 4 plus 4, and here it will be 4 plus 4, and when we will add these two it will be 8, and it will be also 8. Now what we find here is the result of summation is again a two-digit number, which is 8. But in this expression it is given that the result of summation is a three-digit number. Though these two digits are replaced by alphabets, but still it is a three-digit number. That means A is equal to 4 is not possible. This solution is not possible. So we will go to the case 2 or the second possibility where a is equal to 9. Now if we put 9 9 and again 9 9 will be added with another 9 9, so 9 plus 9 it will be 18, 18 and 1 will be carried forward to the tens place, so it will be 9 plus 9 18, and if we add 1 with that then it will be 19, 19, so here it will be 9 and here it will be 1. That means we, and in this result of summation we are getting the 3-digit number, and we took a as 9, and the result of summation was given b, a and 8. Now if we compare this value with this, then 8 is 8 here is fine. Now in the second, in the tens position in the result of summation, it was a, and a we took already as 9, and here also it is 9, it is coming as 9, so it is also matching. Now in the third position in the result of summation, it was given b, and we are getting here 1. So since a is getting satisfied, so b will be here 1. So the final answer for this problem will be a will be equal to 9 and b will be equal to 1. Now we will go to the next problem. The next problem has again it is related to summation, and here we are adding to 4-digit number, and the result of summation also a 4-digit number. Now here the alphabets are a, b, c, 3 unknowns here we have. Now in the first position we are adding 5 with a, and the result of summation, at least in the units place, it will have 2. Now again a will have will accept values from 0 to 9. Now we will check for every possibility of a. Now if we take, we'll start with 0. Now if we take a is equal to 0, so 5 plus 0 cannot be 2, 5 plus, now next 1, so 5 plus 1 cannot be 2, 5 plus 2 it is 7, 5 plus 3 it is 8, 5 plus 4 it is 9, 5 plus 5 10, at units place it is 0, so not possible. Then 5 plus 6 it is 11, again not possible. 5 plus 7 is 12, and at units place the digit is 2. That means one possibility of a having the numeric value is 7. 5 plus 7 12, at units place the value is 2. Now 5 plus 8 is 13, not possible. 5 plus 9 it is 14, again not possible. So only possible value of a is 7. So 5 plus a, now only possible value as I said will be 7. So when these two will be added, it will be 12 and 12. So at units place it will be 2 and 1 will be carried forward here. Then here we have 4 and we have b here, and again it is a. A means a has already been determined, and that is 7. So here we will write 7. So 4 plus 1 5, and with 5 another some value will be added, so that the result of summation will be 7, and that value is b. And numerically if we go, then 5 plus 2 will be 7. That means b will be, now if we write the answer here, if we keep the record, then a will be 7. This is the only possible value of a, and if we go by that value of a, then b will be 2. 5 plus 2 will be 7. Now if we go to the hundreds place, then it is 3, and then here we have 9, and b has already been here. The result of summation will be b, or at units place that will be b. Now b has already been finalized, has already been determined, and that is 2. And when 3 plus 9 is added, that is 12. So at units place that is 2, and 1 will be carried forward to thousands place, and here we have b and here we have c, and the result of summation is 8. Now b has already been determined, which is 2. So here 2 plus 1 3, and the result of summation is 8. That means 8 minus 3, c will be 5. So that is the only possible value of 5, and this is the way how we find the values of alphabets in terms of numerics. So this is simple, right? Now we'll go to the next exercise, and that is again related to summation. Here again we are adding two 4-digit numbers, and the result of summation, as we can see here, this is again a 4-digit number. Now at units place we are adding two b's. We are getting the result of summation as 6. Now b plus b, Again, it can accept from 0 to 9. Now, if we start with 0, then 0 plus 0 is 0, not possible. 1 plus 1 is 1, not possible. 2 plus 2, 4, not possible. 3 plus 3 is 6, and that is the first possibility of B. This is the first possible value of B. Now we will go further. Then 4 plus 4, 8, not possible. 5 plus 5, 10, not possible. 6 plus 6, 12, not possible. 7 plus 7, 14, not possible. 8 plus 8, 16, possible, because at units place the digit is 6. So second possible value is 8. At units place it will be 6. Then 9 plus 9, 18, not possible. Now first case, when B has 3. So we will go by that value first, and we will check whether B can accept both the values or any one of them. Either of them it can accept. So now when B plus B, if we take B as 3, then it will be 6. So fine. Now we will be writing 3 here and 3 here. Then at tens place, if we come, then it is 1 and this is 8, and this result is coming as 9. So nothing is carried forward from the units place. That means if we add 1 with A, and if that result is 9, then A must be 8. So that is the possible value of A when B is 3. So this is 8. Fine. Now we'll go to the hundreds place, and this is 2 and this is C, and the result of summation is 4. Okay. Now 2, nothing is carried forward from the tens place. So 2, when it will be added with C, and if the result of addition is 4, then C has to be 2 again. Now we'll move to the thousands place, and here A is added with 1, and that result of addition is B. Now B we have already found, and that is 3. So in place of B we will be writing 3. Now when A is added with 1, and that result, if it is 3, then A has to be 2. But here what we can see is A has already been finalized or evaluated as 8. And here we are contradicting the previous value. Here only if A is 2, then that will match with 3, where when B was taken as 3. So this is not possible. So this value, when initially we took B as 3, that is not possible. So we will go to the second value, possible value of B, which is 8. And we will evaluate the whole addition, and we will see whether there is any contradiction or not. Now when B is equal to 8, so at units place B plus B, and that is 16. So B plus B, that is 6. So when we will take 8, so 8 plus 8, 16. Here we at units place will write 6, and 1 will be carried forward to tens place, and now here we have 1, and here we have A. And as the result of this addition, we are having here 9. Now 1 plus 1, 2. With 2, if we add 7, then the result of addition will be 9. So when B is equal to 8, then the possible value of A will be 7, and then only we will be getting 2 plus 7, and then we will be getting in the result at units place 9. Now if we go to the hundreds place, then 2 plus C, it is 4, and nothing is carried forward here at the hundreds place from tens place. So 2 plus C, if it is 4, then 2 plus 2, it will be 4. So the possible value of C, it will be 2. Fine. Now at thousands place, it is A, and then here it is 1, and we have here B. Now A has already been determined, and that is 7, and B also has already been accepted as 8 when we started. Then 7, it is 7 and it is 1. So 7 plus 1, here B was 8, and this is matching. We don't have here any contradiction. That means this value is possible. So when B is equal to 8, every other thing is getting matched. So B is equal to 8, that value we can accept, and if we go by that value, then for A we are getting 7, and for C we are getting value 2, and these are the only alphabets that we had in this expression. So the final answer of ABC here will be A is equal to 7, B is equal to 8, and C will be equal to true. So this is how we solve this type of addition related to cryptarithm. Now next we will see a subtraction involving digits and alphabets. Now here AB, from AB we are subtracting B6, and as a result of subtraction we are getting 47. So we'll go place by place. So at units place we have B, and from B we are subtracting 6, and as a result of subtraction we are getting 7. Now as we know, we can have value from 0 to 9. Now if from 0 we subtract 6, then we cannot have 7. Even if we borrow 10 from 10's place, and if from 10 if we subtract 6, then also the result of subtraction is not 7, that will be 4. Now B, if it is suppose 1, then from 1 we cannot subtract 6. Even when B is less than 6, till then we cannot subtract, and we cannot because the result of subtraction would be negative. So we have to borrow something. I mean, we have to borrow 10 from the tens place. Now 1, that means if we borrow 10 plus 1 it will be 11. 11 minus 6 it will be 5. Not possible. Now when it is 2, and if we subtract from 12 6, then it will be 6. Not possible. Now if it is 3, suppose. If it is 3, if we borrow 10 from the tens place, then it will be 10 plus 3, 13. And from 13, if we subtract 6, then it will be 7. Then it is possible. That means the possible value of B, it is 3. Now at tens place, we are subtracting B from A. Here it was 13. So since B was 3, and we subtracted 6 from 13, and we borrowed 10 from the tens place. That means A will no more remain A, it will be A minus 1. Here is, it follows the normal rule of subtraction, so it will be now A minus 1, and here it is. So from A minus 1 now we will subtract B, and as the result of subtraction we will be getting 4. So A minus 1 it is. Then from there we will subtract B, and the result of subtraction will be 4, and B has already been fixed, and that is 3. So it will be A minus 1 minus 3, and that will be equal to 4. So it will be A will be equal to 4 here, and minus 4 from here. So it will go to the other side, and it will become 8. So A is equal to 8. That means our final answer is A is equal to 8 and B is equal to 3. Let's check this with normal subtraction. So A is equal to 8 and B is equal to 3. So 83, and here it is 36. And if we do the normal subtraction, then it is 3. From 3 we are subtracting 6. So we have to borrow 10 from here. So 10 plus 3, 13. 13 minus 6, it will be 7. So when we are subtracting 10 from 80, then it will become 70. 70 means here the digit wise it will be 7. So 7 minus 3, when we will subtract, it will be 47. So it is matching. This is not contradicting. So this is how we solve problem of subtraction related to cryptarithm. Now this is an interesting problem where we have multiplication. This looks simple. Let's see whether really it is a simple problem or not. Now AB, when it is multiplied by 6, the result of multiplication is triple B. So here we are multiplying a 2-digit number by 6, and as a result of multiplication we are getting a 3-digit number. Now again B will start from units place. B can have values from 0 to 9. Let's start with 0. So 0, when it will be multiplied by 6, that result will be 0 only. So first possible value of B, it is 0. Now second possible value of B, if it is 1, 1 multiplied by 6, that is 6. So it is not possible because it has to be 1 here. If it is 2, B is equal to 2. 2 multiplied by 6, it is 12. And at units place, the digit is 2. So it is possible. So the next possible value of B is 2. Now if we take B is equal to 3, 3 6 are 18. So at units place the digit is 8, but it has to be 3. So since it is not, so the possible value of B cannot be 3. Now if B is equal to 4, 4 6 are 24, and 24 at units place the digit is 4. So next possible value of B is 4. Now 5 6 are 30, not possible. 6 6 are 36 at units place. it is 6, so it is possible. So b is equal to 6 possible. Now b 7, 7 6 are 42, not possible. When b is equal to 8, 8 6 are 48, and at ones place or units place it is 8 again. So again the next possible value of b is 8. Now b, if it is 9, 9 6 54, not possible. So here we have obtained 5 possible values of b, and we have to evaluate every possible value of e, and finally we have to see whether among these 5 how many are possible, really possible for b. So we will go one by one. Now suppose when b is equal to 0, the first case, if b is equal to 0, that means 10. Here it is AB. AB means 10A plus B, and when that will be multiplied by 6, the result will be, it is triple B, so it is 1000B plus 10B plus B. So this is the format that we will use for every possible value of B. Now if we again rearrange, then it will be 60A, then it will be 6B, and it will be 100B plus 10B. Okay, 10B plus B, it will be 11B, and here we have 100, so 111B. Now if we rearrange all the terms, then it will be, and for we have to see that which combination of A and B, for which values of A and B this equation or this expression will be satisfied. Now if we go by the first possible value of b, which is 0, so if we put 0 here, then it will be 60a, and that will be equal to 0. So 60a that is equal to 0 means a is also 0, so that is not possible. This is absurd value where a and b both are 0, so this expression will no more remain. Now we will go by the second possible value of b, which is 2. Now 60a, for this possible value, 60a minus 105, and if we put the value of b as 2, and that is equal to 0. So a will be what? A will be 105 multiplied by 2, that means 210, and divided by 60. So it is 21 by 6, and we can easily here see that this 21 by 6, this is a fractional number. So since a and b, both of them will be an integer, and that will be from 0 to 9. So this is not possible. This is not possible value of a, 21 by 6 or 7 by 2, that means 3.5. 3.5 are fractional number, so it cannot be the value of a, that means b is equal to 2 is also not possible. Now the third possibility is b is equal to 4. So b is equal to 4 means if we put the value of b in this expression, then 60a minus 105 into 4, and that is equal to 0. So it will be a will be equal to 105 multiplied by 4, that means 420, and divided by 60. So it is 7, and here the value of a is an integer. So a is equal to 7 and b is equal to 4. This combination is possible, but we have to still check whether for the other two values of b, where b is equal to 6 and 8, whether we are getting or will be getting integer value of a or not. So let's evaluate the fourth case where b is equal to 6. Now if we put b is equal to 60a, then minus 105 multiplied by 6, and that is equal to 0. So from here the value of a that we will be getting is 105 multiplied by 6, means here it will be 630, and that will be divided by 60. So again it will be 21 by 2, so which is a fractional number 10.5. so this value of a is not possible. Again, next the last value of b we will assess or evaluate, so that is 8. And if we put in this expression the value of b as 8, so 60a minus 105 multiplied by 8, which is equal to 0. So from here the value of 8 that we will be getting is 8, and it will be 40 divided by 60. So this value will be 14, and this is again an integer. So this combination is also possible where b is equal to 8 and a is equal to 14. So b is equal to 8, a is equal to 14. This is also possible combination of a and b. So apparently it seems that there are two combinations, two possible combinations, but it is not. The first reason is the value of a and b will lie between 0 and 9. So if we go by this combination, here we can see a is equal to 7, which is satisfying the condition. B is also 4, which is also again satisfying the condition. But if we look at this combination, here b is 8, that is okay, but a is equal to 14, a 2-digit number, so it is not satisfying the criteria. Now if we evaluate with this real values, then a is equal to 7 and b is equal to 4, and when we multiply that by 6, then it is 4 6 are 24, so 2, and 7 6 are 42 plus 2 44. So here we are getting triple 4, that means triple b, and b also we took as 4. Now if we go by these values, then 14, and here as b we are getting 8, we have obtained 8, and when we will be multiplying by 6, here it will be 8, and here also we are getting triple 8, so it is matching also with this format triple b, and b also we took as 8. So both the combinations of a and b, this is matching with the result or the format that it is given as the result of multiplication. But if a has to have the values between 0 to 9, then only this combination is possible. Otherwise, if a can have values more than 9, if it can be a 2-digit number, then in that case only this combination is possible. But in our case, we assume that both a and b will have values between 0 and 9. So for our case, only possible combination is this. Now we will solve another problem related to multiplication and cryptarithm, where we can see here ab, a 2-digit number, is multiplied by itself, which is again AB, and as the result of multiplication we are getting a 3-digit number, and this whole expression we have only one digit, 6, and two alphabets A and B. So here what first we will express this multiplication in the form of equation that we did in the previous problem. So AB means it will be 10A plus B. This concept we have already learned in the class where I discussed about 2-digit number, the mathematical explanation. Now 10A plus B, and that is again multiplied by the same number, which is 10A plus B, and that result of multiplication is 6AB. 6AB means 6 multiplied by 100. Since 6 we have at hundreds place, so it will be 600, then 10A, then plus B. So from the left hand side it is 100A square, then it is 10AB, then again it will be 10AB, and then B square, and on the right side it will be 600 plus 10A plus B. So now if we simplify further, then it will be 100A square, then it will be 20AB, then we have 10A here. So if we take on the left side, then it is minus 10A, then we have B square, so it will be plus B square, then we have B here, so when it will come to the other side it will be minus B, and that will be equal to 600, or if we take 600 also on the left side, then it will be minus 600. So let's recheck. It is 100A square, then 10AB plus 10AB 20AB, then here we have 10A, so when we will take on the other side of that equation it will be minus 10A, then here we have plus B square, so that will remain as plus B square, then plus B will come this side, then minus B, and 600 also minus 600, and that will be that will be equal to 0, and this is our final equation. Now here we are multiplying B by B, and as the result we are having B. Or maybe if we will be getting a 2-digit number as the result of multiplication of these 2 digits at units place or ones place, the digit will be B. Now let's check what are the possibilities of B. So if it is 0 0, then also 0 when it will be multiplied by 0, so that result will be 0, so this is possible. Now second case is 1 1, when they will be multiplied, then it will be 1. So that is also possible. 2 when they are multiplied, it becomes 4 as a result of multiplication at units place. So it is not possible. Now 3 3 9 not possible. 4 4 16 not possible. 5 5 when 5 is multiplied by 5, it is 25 at units place, it is 5. So next possible value of B is 5. Fine. 6 when it is multiplied by 6, it is 36. So at units place it is 6. So B is equal to 6. That is also maybe possible. Then 7 7 49 not possible. 8 8 64 not possible. 9 9 81 at units place 1 not possible. So these are the 4 possible values of B, and now we have to further evaluate whether among these 4 which one is really possible. Now if we go by the first value where B is equal to 0, now if we put in this equation, then it will be 100 a square. B is 0 means this will vanish. Then minus 10a and B square will vanish, B will vanish, so it will be 600 and that will be equal to 0. So from here further if we divide the whole equation by 10, then it will be 10a square minus a and it will be minus 60 and that will be equal to 0. Now this is a quadratic equation of a, and if we solve for a, then as per the rule or as per the formula, it will be minus b. The formula is minus b plus minus root over b square minus 4ac divided by 2a. So in this case, what are the values of a, b and c from this equation? A, the coefficient of a square, the value of small a is equal to 10. B is what? B is the coefficient of a. B is coefficient of a means here it will be minus 1 minus a, that means minus 1 is multiplied by a, capital A. And c is what? C is the constant coefficient. This rule we already know, and that is minus 60 here. So these are the values. Now if we put these values in this equation, then we will see that from here we will be getting two values of a. This is a quadratic equation, so will be a will have, when we will simplify for a, we will have two values. And if we put these three values of small a, b and c in this equation or in this formula, the values that we will be getting for a, we will see both the values are not integers, or rather both the values will come as fraction. So since the values of a and b will be integer and that will be between 0 to 9, so this combination is not possible. That means value of b where it is 0 is not possible. Now we'll go for the second possible value of b, which is 1. So this is not possible. Next we will check for 1. So when b is equal to 1, this value will be putting in this equation. So 100 a square, then b is equal to 1 means it will be 20a. So plus 20a, then again b where we have minus 10a, then b square, so it will be 1 and here b is equal to 1. So 1 plus 1 and minus 1 will cancel each other, and I am not writing here. So it will be next value is minus 600 and that will be equal to 0. So further if we simplify this, then it will be 100 a square, then we have 10a and then minus 600 and that will be equal to 0. So if we divide the whole equation by 10, then it will be 10 a square, then plus a and then minus 60, that will be equal to 0. It is similar to this equation, only difference is here the coefficient of a is minus 1, here the coefficient of a is plus 1. Now again if we go by this formula, if we put the values here, the value of a, b, c what? A will be equal to 10, the coefficient of a square, capital A square, and then the coefficient of b will be plus 1 and the coefficient of a will be plus 1, the value of small b, and here the value of c will be minus 60. And if we go by these values and if we put into this formula, then again we will see that both the values of a will come in fraction. So since a will be coming, both the values of a will be coming in fraction, so b is equal to 1, this value is not possible. So this possibility also gone. Then next the two other possibilities of b is equal to 5 and b is equal to 6. So here first we will First we will write the equation. So the third possibility of b is equal to 5, and that value we will put in this equation. So 100a square, then 20ab, b is equal to 5 means 5, 20 are 100, so it will be 100a. Now a minus 10a, then b square, b is equal to 5 means here it will be 25, then minus b, so minus 5, then minus 600, and that is equal to 0. So here it will be 100a square, then 100a minus 10a, so it will be 90a, then 25 minus 5, it is 20, plus 20 minus 600, it will be minus 580. As if we are subtracting 20 from 600, so it is 580. So if it is minus, if it is plus, then it will be minus 580. So it is minus 580. Now at the end of all the coefficients we have 0. So if we divide the whole equation by 10, then the modified equation will be 10a square, then it will be 9a, then here it will be 58, and that will be equal to 0. Now again here it is a quadratic equation of a, and if we go by that formula, we can easily find both the values of a. Otherwise, if we go by the concept of factorization, then 58 multiplied by 10, it will be 580. And if we find the factors of 580, then it will be, we can first divide by 10, then it will be 58, and then if we divide by 2, so it will be 29. So the factors are 2, 10 and 29, and that will be equal to 580. So here 2 and multiplied by 10, that will be 20, and here it is 29. So that will be equal to 580, and 29, if we subtract 20 from 29, then it will be 9. So here how we can rearrange or how we can factorize is 10a square, then we can write this way. It will be 29a minus 20a. So 29a minus 20a, it will be 9a only, and 29a and 20a minus 20a, if we multiply, then it will give us 580a square. That is the rule of factorization. Now if we split this way, or if we rearrange the terms this way, 10a square, then 29a we can take as a group or as a combination, then minus, if we take common, then minus 20a, so it will be 20a inside, then plus 58, and that will be equal to 0. So from here only a is common, and inside the bracket it will be 10a, and then here it will have 29, and minus, between these two terms 2 is common. So if we take 2 common, then it will be 10a. 10a multiplied by 2 is 20a, and here it will be 29. 29 multiplied by 2, it will be 58, and that will be equal to 0. So further if we rearrange, then 10a plus 29 is common, so we will take that as common. That is the rule of factorization. And what remains here as second factor, it will be a, and from here it will be minus 2. Now this is equal to 0. That means, as we know from the rule of factorization, this is the separate, this is represented, this has been represented as a multiplication of two factors. So separately both the factors will be equal to 0. So 10a plus 29, that will be equal to 0. So from here a will be minus 29 by 10, which is minus 2.9. So that is not possible because it is coming in fraction. And a minus 2, that is equal to 0. So a is equal to 2. A is equal to 2, that is coming in integer, or that is coming as an integer. So that is possible. So when b is equal to 5, a will be equal to 2. That is one possible combination. But still we have the third possibility of b, which is b is equal to 6, that we have already checked. That b, when b is equal to 6, that could be also possible. So b is equal to 6, Again the same process. So if we simplify further, then it will be 100a square, then 120 minus 10, so it will be plus 110a, then 36 minus 6 is 30, and 30 minus 600, it will be minus 570, and that is equal to 0. Now again 10 is common, so if we divide by 10 the whole equation, so it will be 10a square, then it will be 11a, then it will be minus 57, and that is equal to 0. 57 multiplied by 10, it is 570. So 570, again if we factorize, so first if we divide by 10, then it will be 57. 57 also divisible by 3. So 5 plus 7 is 12, so divisible by 3, so it will be 1, and then it will be 19. So the three factors are 3, 9, 10 and 19. And if we go by the concept that we have already applied here, or the concept of factorization that we know, then we can rearrange this way, that 11a we have to adjust here, we have to get here. So it could be 30a minus 19a. 30a minus 19a will give us 11a here, and 30a minus 19, when 30a will be multiplied by minus 19a, then it will be minus 570a square. So we can further rearrange the equation this way: 10a square, then plus 30a minus 19a. This is the rule of factorization, and this is minus 57. So that is equal to 0. And if we split both the terms, so if we 30a, if we combine with 10a square, then 10a square plus 30a, this is one combination, and then here from here minus common if we take, then it will be 19a plus 57, and that is equal to 0. So further, if we take from here a is common, also 10 is common, so 10a if we take common, then from here it will be a, then it will be 3, and from here 19 can be taken, 19 is the common factor, so it will be a plus 3 again, and that is equal to 0. So both the factors of this equation will be, one will be a plus 3, which is common as we can see here, and the other factor will be 10a minus 19, and that is equal to 0. Since this class is not about factorization, so I will assume that you already have the concept of factorization. I am not going into detail of factorization. So here it will be separately, both the factors will be equal to 0. So 10a minus 19 will be equal to 0. From here a will be equal to minus 3, and from here 10a will be equal to 19. So a will be equal to 19 divided by 10, that is 1.9, and from here a is equal to minus 3. A is equal to 1.9, this is coming in decimal or fraction, so this is not possible, as we know that a will have values from 0 to 9. Again if we go to this value, and this is a is equal to minus 3, which is a negative integer. So this negative value is also not possible. The value of a will be positive, and this will be integer, and that will be between 0 to 9. So this combination is also not possible. So we started from this page. So b is equal to 0, not possible. B is equal to 1, not possible. B is equal to 5, we saw that it was possible, but b is equal to 6 is not possible. So only possible combination for this cryptarithm, for this multiplication, is b is equal to 5 and a is equal to 2. So the only possible combination is a is equal to 2 and b is equal to 5. I hope this class was interesting for you and you have learned an interesting thing of mathematics. So with this I end today's class. Thank you.